Hello everyone. Today we're going to do a pre-lab about hydrated compounds. Yesterday we talked a little bit about it. Hydrated compound would be like a sponge that's got water locked up inside of it. And what we need to do is find out how many grams of water are actually inside the sponge or the hydrated compound. Then we can calculate the percent of water that's inside the hydrated compound. And then that'll lead us to what number of water molecules are actually in the hydrated compound. So we'll start with going over this top part. It says many ionic compounds are hydrated. This means that they have water attached to the rest of the molecule. On the other hand, anhydrous is given to compounds that have no water attached. So a dry sponge would be like an anhydrous compound. Water inside the sponge would be like a hydrated compound. Formulas for hydrated compounds show water as a kind of addition to the main formula of the compound. For example, iron 3 chloride hexahydrate has 6 water molecules attached to it in the hydrated state. And the formula is written FeCl3.6H2O. Anhydrous iron 3 chloride is just FeCl3, no water molecules attached to it. So we're going to go over some math, and we're going to try to figure out the percent water in this compound. So we're going to be doing it for iron 3 chloride hexahydrate. I have the formula right up here on top. And our goal is to calculate the percent water for this compound. So FeCl3, we take it, we break it apart. Fe, there's one of these Fe's. There's one Fe. And then I go to the periodic table and I get its molar mass. And this is the mass of the Fe in this compound. And now I go to chlorine. And if I look up here, there are 3 Cl's in this compound. So that's where that 3 comes from. This is the molar mass off of the periodic table. So 3 times 35.45. And I get this many grams of chlorine. And then the last part we have is the H2Os. And we're going to figure out H2O altogether. We're not going to break it apart. And if we look here in this compound, we have 6 H2Os. So that's where this 6 comes from. This is the molar mass of H2O. So oxygen is 16.00 plus 1 hydrogen plus another hydrogen. That's H2O. And that gives us a grand total of 108.00 grams total for H2O. So what I'm going to do is I'm going to add all of that together, and I'm going to get this grand total. So the total mass of iron 3 chloride hexahydrate has a mass of 270.20 grams. So I want to figure out the percent water in this compound. That is my goal. What is the percent water in this compound? So when I calculate the percents of anything, I put the part I want to know about on top. I put the whole thing or the total thing on the bottom times 100, and that gives me my percent. So in this problem, I want the percent water, so I put the grams of water on top. And if I look at that, my grams of water are 108.00. So I put 108.00 grams on top. What's the whole thing? It's not just the iron, it's not just the chlorine, it's not just the water. This is the whole thing, this 270.20. That is the total mass. So 207.20 times 100 will equal our percent. So if you do that math, you end up getting 39.970% water. And this work is meant to be done right there. So if you were in class today, I would have you do this problem all by yourself to make sure you could figure it out. This one is done with iron 3 chloride trihydrate. And you're supposed to come up with the formula and the percent water by going through all the steps. So if you're at home, pause the video, try to do this on your own. You'll learn more by trying to do it on your own rather than just watching this video. So the formula is FeCl3.3H2O. A lot of the work is the same. I have 1 Fe, I have 3 Cls, I get the mass, Here I have 3 waters. So 3 times 18 in this case is 54.00 grams. I add all this up together and I get 216.20 grams. That is the whole thing. So that's the mass of the Fe, the Cl, and the H2O. To get the percent, I do part divided by total. The part I want to know about goes on top. That's the grams of water. The whole thing is this 216.20. So 216.20, that is the mass of the whole thing, times 100, a 4-digit number divided by a 5-digit number. And I end up getting 24.98% H2O. So again, the formula is always part divided by total. The part you want to know about on top, the whole thing on the bottom. So we're going to come back to the 2% that we calculated in these 2 problems in this next problem. So here I'd like you to read this and see how much of it you can solve. If you can figure out all of this on your own, that would be absolutely awesome. And it means that you grasp how to take the worded language of chemistry and actually turn it into the information that you need. If you can't do this, it means you're a little weak in that skill. So I'm hoping you pause the video. If we go through this, it says, in a simple experiment, 2 chemistry students took 3.68 grams of hydrated iron 3 chloride and heated it with a Bunsen burner. So what's the mass of the hydrate? Well, that's that 3.68. What's the mass of the anhydrous residue? After cooling the beaker and subtracting the weight of the beaker, there was only 2.21 grams of substance left. So they took the 3.68, they heated it up, and at the end there was only 2.21 grams left in the beaker. What didn't evaporate away must be the anhydrous residue, or the anhydrous compound. How much water was lost? Well, this is everything, this 3.68. This is just the compound without any water. So if I take 3.68 and I subtract 2.21, the amount that is different, that was the mass of the water. So I took 3.68 and minus 2.21. What's the percent water in the hydrate? Well, we just talked about that. Percent is always part divided by total. The part I want to know about goes on top. So 1.47 grams, that's my water. That's what I want to know about. What's the whole thing? This is the whole thing. This is my wet sponge like I talked about at the beginning of this video. So 3.68 grams times 100. I do the math on that, and I end up getting 39.9% water in this compound. So now it wants to know the formula of the hydrate. In other words, how many water molecules are attached to it? So if I go back, remember 39.9 is the number to remember. If I go back one slide, this one had 24.98% water. This one had 39.970% water. This one is much closer to what I just calculated. So in this one, we have 6 H2Os that are in the compound. So we go back to our original information, and we are going to realize that the formula is FeCl3.6H2O. So on the back side, everyone at home is going to do magnesium sulfate. So you should circle that one. Everyone at home is going to do magnesium sulfate. You're going to work through that data, and we're going to try to figure out how many water molecules are in magnesium sulfate. So we're on the back side right now if you haven't realized that yet. So you got to fill out this chart for magnesium sulfate. So what is the formula for magnesium sulfate? So we got Mg and we got SO4. And magnesium, we need to figure out its charge. and its charge is a 2 positive. And sulfate, which is a polyatomic ion, so it's found on the backside of the periodic table, is a 2 negative. So our formula is MgSO4. And if we look here, it doesn't have any water molecules attached to it. It's anhydrous, or what we would call dehydrated. Molar mass of the water molecules, so just the mass of the water molecules. So there's 0 water molecules in this compound. So 0 times 18 equals 0 grams per mole. What's the total molar mass of the compound? Well, we'd have to look it up on the periodic table. We'd have to find the mass of 1 Mg, 1 S, and 4 oxygens. Pause the video, do that. Hopefully it did do that. You got 120.36 grams per mole. And then the percent water in the compound. Well, there's 0 grams of water in the compound. And the total mass of the compound is 120.36 grams per mole times 100. So you're going to get 0% water in the compound. We're going to do one more, and I'll get you the feel for what's going on. And then you're on your own to fill out the rest of them for magnesium sulfate. So now we're going to pretend that this magnesium sulfate has 1 water molecule to it. So the formula would be MgSO4 dot 1H2O. And if it had 2 water molecules in it, it would be MgSO4 2H2O. So that's what you do all the way down the line. So for the monohydrate, how many water molecules are there? There's 1 times 18, and you're going to show your work just like this as we're going through it. And that's going to be 18.00 grams per mole. So I put that down. What's the total mass of the compound? Well, I'm going to have this 120.36, that's the dry, plus this 18 right there. So if I do the math on that, it's 138.36 grams per mole. So you notice this one, this green one, is 18.00 heavier than this 120.36. So what do you think the mass of the one with the 2 water molecules is going to be in it? Well, I'm guessing it's going to be 120.36 plus 18 plus another 18 because there's 2 water molecules there. What's the percent water? Well, if I did the math, 18.00 divided by 138.36 times 100. And if I do the math, I get 13.01%. So I'm going to have you do that work, do the rest of the work. I will give you a couple numbers, and you can check if you're going and doing things correct. So for this dihydrate, I will give you this number, 23.02%. If you don't get 23.02%, you are doing it wrong. So that's one little bit of information. I'll give you this trihydrate mass, 174.36 grams per mole. If you don't get that molar mass, you're doing stuff wrong. By filling out this chart, what we're going to do is when we do the lab tomorrow, you will put some compound into a container. You'll get the mass of that compound. You'll heat it up. Water will be driven off. We'll take the mass of the dry stuff. We'll figure out how many grams of water you have in the compound. And then what we'll do is we'll find that percent. So you'll take the water you have in the compound, the grams of water. You'll divide it by how much you started with, just like we did on this first page. So if we go back, right here, how did we calculate this percent water? We took the mass of the water and we divided it by the whole thing times 100. That's how we found the percent water. So when we find that percent water, we'll match it up to our chart here. And the one that comes the closest, that is how many water molecules you have. So it might be the one with 2 water molecules. It might be the one with 3 water molecules. It might be the one with 7 water molecules. That's how we'll find it out. So that's how we'll do the lab tomorrow. So, in the wise words of Looney Tunes, yabbity yabbity yabbita, that's all, folks.